Hello, people. I don't know if you can hear me. I stated in the lecture that the lab was going to be at 7:30 today. So unless there's an objection, I'm going to hold off and do as I stated. Any questions? All right, so our lab's going to be at 7:30 today because I got my times wrong in the lecture. Okay, are there any questions? All right, could somebody please confirm that you can hear me and see my screen?
Yes, we can
Thank
hear
you.
and see.
You probably weren't hearing me very good. My microphone was way up by my eye. Today we're doing Lab 3 Microscope Basics. I've already talked about reading Chapter 3 of the textbook beforehand, and not all of Chapter 3, just the part on compound light microscopy. And we've already discussed the infectious disease project. Are there any questions on the infectious disease project? I've only got one email, so that means nobody's decided on what projects you wanted to do. So think about what project you want to do it on and then email me and I'll approve it or tell you to pick another topic. If there's no other questions, let's go ahead and begin. So today we're doing Lab 3, Microscope Basics. You need to read this lab module and the textbook on Chapter 3 concerning the microscope. It's only a section on compound light microscopy. You're not physically going to be using a microscope. However, upon completion of this lab, you should be able to locate and name the parts of a compound light microscope along with describing their functions. You should be able to calculate the total magnification for each objective lens used. You should be able to know the guidelines for focusing on a specimen with the different objectives, and you should know the names of the objectives. What's the scanning objective, the low power objective, the high power objective, and the oil immersion objective. Note that the low power objective is not the lowest, and the high power objective is not the highest. That's one reason why I don't particularly use these names. I always use the 4x objective, the 10x objective, the 40x objective, and the 100x objective. You should be able to estimate the size of a specimen when you see it at the different magnification powers. And how you do that is know the objective lens, know the total magnification, and know the size of the field of view of that objective lens. And we'll discuss that in this lab today. Understand the rules for proper microscope care. You're not going to be using a microscope, but you do know how to properly use one, properly put one away, and then be able to define the terms associated with the microscope. All right, you need to memorize the names of these parts of the microscope. 1, the ocular lens. 2, the objective lens. 3, the stage. 4, the stage clip. Where's 5? There it is. That's the, what is that called? The dial for moving the stage clip. There's another name for that. I forgot what that's called. Mechanical stage control. So it moves the slide on the stage and actually does move this way as well as up and down or forward and backwards. Where's 6? 6 is the iris diaphragm. 7 is the condenser. So in this microscope, it's reversed from the slide I showed you in the lecture. 8, the coarse focus objective coarse focus objective knob. 9, the fine focus objective knob. 10, the power switch, turning the light either on and off. 11, the rheostat, which turns up the light, and that's a different name here, light intensity dial. I call it the rheostat because it controls the amount of light you get. And then 12, the lamp or the light source. And here they are here, as well as some description of them, of what they do. You need to know what they are and what they do. The only one that I will mention is the iris diaphragm control level. It opens and closes the iris diaphragm, which adjusts the amount of light coming up through the specimen and then to the microscope. For the best magnification, the iris diaphragm has to be at a certain open position. And it's called Koehler illumination. And that's because while you adjust the iris diaphragm, you adjust the contrast of the specimen, as well as adjusting the cone of light coming up through the specimen and through the objective lens. Generally, what you do is for the iris diaphragm is you adjust the cone of light so that the size of the cone of light is equal to the field of your objective lens. And the smaller the objective lens, the larger the field of view. So you open up the iris diaphragm to have a larger cone of light. And then as you go up in power in the objective lens, you need to shut down the iris diaphragm to get your best resolution. And that's because the iris diaphragm is adjusting the contrast of the specimen. It's also going to control the amount of light. And so you can use the iris diaphragm to adjust the amount of light coming up and hitting the specimen and going into the objective lens. All right, that's the only one I want to talk about. You should know this table. You should know the names of the objective lens and their power, their magnification power. That's how many times the objective lens itself magnifies. However, the total magnification is the ocular lens times the objective lens. So this is the total magnification for our scopes, because our scopes have a 10x ocular lens. Any question about that? You should also note that the 4x lens has the greatest depth of field, or the deepest depth of field. Meaning if you're looking at an object, I don't know if you can see this, hopefully you can. With the 4x lens, you can see the object, all of it, because it has the deepest depth of field. As you go up in power, you'll have less depth of field, so you will not see all of the object. You may see, I don't know, half of the object. And then you go up in power, you're going to see less of the object until you come to the oil immersion lens, where all you're seeing is essentially one plane of the specimen. So you're only seeing one slice of the specimen because it has the narrowest depth of field. Any question about any of that? Also, the objective lenses have a field of view. The 4X objective lens has the largest field of view. And as you go up in power, the 10X lens has a smaller field of view. The 40X lens, smaller. And then the oil immersion lens, essentially a pinprick for a field of view, the smallest field of view. Comments on using the scanning lens or the 4X objective lens is the easiest to use because it has the deepest depth of field and the largest field of view. And then the 100X objective lens or the oil immersion lens is the hardest to use because it has the smallest depth of field and the smallest field of view. Any questions about that? When you're looking at an object under the microscope, you should realize that it's more than magnified. For example, here is the letter E, and when we look at it under the microscope, you'll see the letter E like this. Its orientation is inverted and reversed. Any question about that? So it's magnified, but inverted and reversed. You should know the methods for adjusting the light. Obviously, there's a light intensity dial that I call the rheostat. The condenser height can adjust the light a little bit, but not very much. And then the greatest one is the iris diaphragm, which opens and closes the iris diaphragm, which affects how much light is coming up, but more importantly, affects the contrast of the specimen against the background of the field of view. And so if you don't have your iris diaphragm adjusted correctly, then when you see a specimen, it may have about the same contrast as the background of the slide, in which case it's not going to show up very well. And that's why you adjust the iris diaphragm to give you a better contrast between the specimen and the background of the slide, which is the glass of the slide. And in general, the diaphragm should be fairly open when you're first looking at the slide with the 4X lens. And then as you go up in power, you should close down the iris diaphragm until you get the 100X objective lens, in which case the iris diaphragm is just a pinprick. But the iris diaphragm is the most important tool in light adjustment. When you first use the microscope, you should unwind the cord and plug it in and only use the scanning objective lens to view your object. That's the 4X power lens. You turn on the light. Why you use the 4X lens is because it has the biggest field of view and the greatest depth of focus. So you'll be able to more easily focus in on the object and see the object with the 4X lens. So you always start with the 4X lens. And then you use the coarse focus adjustment knob, that's the big one, to slowly change the stage, raise or lower the stage to bring the object into focus. And you should also move the slide back and forth so that you make sure you're looking at the object. Carefully adjust the focus with the coarse focus adjustment knob. And then use the fine focus adjustment knob to perfectly adjust the focus of the specimen. From this point on, you should not use the coarse focus knob except with the 4x objective in place. Once you go to a higher objective lens, you should not use the coarse focus knob. And if you accidentally do, you should start all over and focus using the 4x objective. Go back to the 4x objective and use the coarse focus knob to focus in on your specimen. And once you get it focused, don't use the coarse focus again. Only use the fine focus. The reason for that is our microscopes are parafocal. This means that when you focus in on the specimen with one lens, all of the lenses are in focus, or they should be very close to in focus. And generally, when you use lenses that are parafocal, all you need to adjust is the fine focus a little bit, meaning you won't go through a full turn, you'll just go through a partial turn of the fine focus. Before you go up to your higher objective lens, you should always center what you're viewing in the center of your field of view. The reason for this is if you were to view something off on the edge of the 4x lens, and then you go to the 10x lens, the 10x lens will have a smaller, I don't know if you can see that, field of view, and then your specimen will no longer be in the field of view under the microscope. So you always move your specimen to the center of your field of view before you switch objective lenses, mainly before you go up in objective lenses. And then you fine focus, and then you repeat step 9, which is moving your specimen in the center of your field of view, and then switch to a higher objective lens. You do that all the way up until you get to the 100x lens. The 100x lens is special because it requires the use of oil. So when you get your specimen under fine focus with the 40x lens, you rotate the 40x lens away from the slide, but you do not rotate the 100x lens over the specimen. So I guess we'll use another finger there, okay? You rotate it so that neither lens, I don't know how to show that. Maybe go like that. You make it so that neither lens is directly over the specimen, so that one is partly off and the other is partly off. That allows you to have room to put a single drop of oil on the specimen. And then you rotate the lens through that drop of oil so that there will be oil from the glass of the slide to the glass of the objective lens. So there's oil between them. And that means that the 100x objective lens will be very close to the glass of the slide. And when you rotate it in place, it will go through that drop of oil and pick up the oil. That greatly increases the resolution and clarity of the image because oil has this same refractive index as glass. Now, when using oil, you have to remember that you always have to clean the oil off of the objective lens. And there will always be oil on the 100x lens. You should also check the 40x lens, because if you have a drop of oil on your slide, and you happen to rotate the 40x lens through over the slide, the 140x lens will pick up the oil. So you check both the 100x lens and the 40x lens for oil and clean the oil off of the lens. Any question about any of that? All right, I'll let you go through the troubleshooting, read through that on your own. We are going to be doing activity 1, getting the size of the field of view. You're not going to actually perform this activity because everything's going to be done online. And the table for the measurements of the field of view have already been recorded for you. However, you are expected to know the information contained in the table and the formula for 0.5 below. So go through activity 1, where you're going to be measuring the field of view. And normally you'd fill in this table, but because the class is online, the table has been filled in for you. So the objective lens is the scanning objective lens, the 4x magnification. The diameter is 4.5 millimeters or 4,500 micrometers. For the low power objective lens, the magnification is 10x. The diameter is 1.8 millimeters. And the micrometers is 1,800 micrometers. For the high power or the 40x lens, the diameter is 0.45 millimeters, and the diameter is 450 micrometers. Now this, if you were actually measuring it, you have to kind of estimate, because the ruler would only have 1 micrometer, and it is smaller than 1 micrometer. For the oil immersion lens, the magnification is 100x times. The diameter is 0.18 millimeters or 180 micrometers. Why it's important to know the diameter of your field of view is you use the diameter of your field of view for getting an estimate of the size of your specimen that you're observing. For example, if you're using the oil immersion lens and the specimen fills up half of the field of view, then you know the size of your specimen is around 0.09 millimeters in size. Any questions about any of that? All right, so you will be measuring, getting an estimate of the size of some specimens, and how you do that is use this table. In activity 2, you're going to be observing prepared slides. Online students are not going to perform this activity, but you will be using a virtual exercise to perform this activity. And the virtual exercise is either in the worksheet or at the end of this lab module. We expect you to know and understand the material in this exercise. So you do need to do it. There's the procedure for doing it. Go ahead and read through that. For activity 3, that's making a wet mount, hopefully you did this in Biology 160, because online students aren't going to perform this activity, and you're not going to be tested on the procedure. But what you do is you put a drop of water on the slide and then add your specimen to it. And then you put a cover slip over the drop of water. And how you add the cover slip is you add it at a 45-degree angle and then slowly lower the cover slip. The reason why that is that if a air bubble forms, you slowly lower the cover slip, and then the air bubble moves this way and doesn't get in your way for viewing the specimen. All right. Online students will not be handling real microscopes, but you are expected to know how to correctly store and put away a microscope. You also are expected to know how to clean a microscope. And let me state, if you use oil, you should always clean the microscope, and you only clean the lenses with lens paper. You do not use regular paper. You do not use Chem wipes. You only use lens paper. A lens paper is paper that the wood fibers of the paper have been removed. And the wood fibers on regular paper can scratch the lenses and damage the lenses. And the lenses are the most important part and the most expensive part of the microscope. So we don't want to damage the lens. So you only clean them with lens paper. And the only other thing you would ever clean them with might be lens cleaner. You put a little bit of lens cleaner on the lens paper and then clean the lens. But generally, most students would ask me to clean the lens, and I would clean it with the lens cleaner. Go ahead and read for the steps that you need to do for storing your microscope. All right, so you should know the different terms associated with the microscope. Field of view, which I often abbreviate FOV. And then do the laboratory exercises. We have video clips on using a microscope. And then we have a video clip on putting oil on the microscope. So watch those videos and then practice your microscopy skills on the virtual microscope. And let me make sure that's the right link here. Well, is that going to open? So we have a virtual microscope that you're going to use online, if I can get the link. It will take a little bit of time for this to load on your system. It doesn't download anything, but it takes time for the program to totally come up. So this program will show you how to use a microscope. All right, so there's our microscope. We click on it and read what to do, the guide tip. The menu to use the resource guide. Where's the menu? Ah, here it is. So we probably want to do explore. You can take a look at the other thing, and you can also test yourself. That's a bit loud. Let me lower my volume here. That's not the volume switch. Oh. Actually, my volume is pretty good. I don't know why that was so loud. All right, there we go. first thing you need to do is get a slide. And I think I'll take a flat slide, onion root. And then start focusing. We'll do the 4X lens first because it's the easiest. Use the coarse focus. And get it in good focus. Someplace around there. I'll do the fine focus now. Well, the light looks pretty good. Then we'll go up in power. And notice how that's the 10X lens rotates into position. Actually, this looks pretty good. Let's finally focus that. Now, let me see if I can find something right there to focus in on. Let's go up in power. Yeah, a little bit. Not very good, though. Let's see if I can find some chromosomes. Here we go. Right there. And fine focus on that. All right, now we're going to go up in power. And we have to add the immersion oil, which is right here. And add a drop of oil. And let's turn up the light. And fine focus. I might have to do a coarse focus if I can't get that to more finely focus. Yeah, I have to do a little bit of coarse focusing. Now let's change that down. That looks like about as good as I'm going to get it. Then we're done. You got to clean the microscope. There's the lens paper there. Let's see, how do I end this? Remove slide. It tells you to use the lens paper to clean the scope. And there we go, cleaning our objective lens. And you notice that the box opened, we put away the slide. Anyways, that's a tip tool for using a microscope. So please practice on your virtual microscope because, well, the virtual labs are probably the best part of this lab where you're actually going to do something in the lab. And then work on the exercises. You can practice naming the parts of the microscope by coming to microscope labeling. And I think this is a quiz. Not a quiz, but this is the tube. So that's the ocular lens. Click start. I don't think we need to do that, but maybe you do. Oh no, I click here. Sorry, you click the button there and here. All right, you click there to get the answer. And how do I switch for what that is? Sorry, it's been a while since I've used this and I don't remember how you use it. Oh, coarse adjustment knob. There it is, it's right there. So that is number 12. And then the stage is this one right here. I'm not sure what number that is. Probably number 6. Low power objective lens. Here. And then you can go through and it'll tell you what your score was. Okay? Any questions? And then do the parts. Let's go ahead and go to the worksheet. Fill in the blanks with the correct answers. A, when focusing a specimen, you should always start with what objective? So answer the questions. Excuse me.
Bless you.
Yeah, thank you. Answer the questions, fill in the answer. And I will mention that when it's asking how large is the field of view when using the high power objective lens, you need to tell me the size in millimeters or micrometers. You can't just say large or small, okay? That's one that I remember students frequently get the question wrong, meaning you need to go in there and say what the size is, okay? So answer those questions and then answer question number 2. Suppose the typical bacteria cell is 2 micrometers in diameter. In the circle below, which represents the field of view of the microscope, when viewed with the oil immersion objective, state how many cells can fit across the circle here under the oil immersion lens. So what do you need to do to answer this question? Well, you need to know what size of the field of view is, and that you can get from the lab module. And then you take that size and divide by 2 micrometers to tell me how many cells will fit across this field of view. All right, any questions? If not, I will be here until about 9 o'clock to answer questions. You should try and use me as a resource. I really am here to answer questions. And I'm the only instructor who stays online during the lab to answer questions. At least the only microbiology instructor. But go ahead and get started on lab module 3. And I will be here until 9 o'clock.